Hello all. So today we are going to discuss about embedded system laboratory, which is 18ECL66. Okay, so this syllabus is highly concentrated towards VTU students who are there in electronics and communication branch 6th semester. Okay. So the one kit that we are using it for program is ARM kit, which is having an LPC1768. Okay, its name is LPC1768. Okay, that's what the board that we are using it. Okay, so in this board you can see that there is a motherboard over here, which is nothing but LPC1768 chip. Okay, so this chip there are many things have been connected, many components have been connected. So you can see that this is a relay. This whatever it has been shown is a relay, right? And then there is one more called as interrupt switch is there. Okay, there is interrupt switch is there, and then there are some external switches are also there, correct? And this one you can see that this is a LCD display. This whatever we have used, okay, it is getting shown as an LCD display. Anyway, this I guess every student will answer this. This is nothing but what? 7-segment display. This is nothing but what? 7-segment display. Okay, and this is the power cord that has been shown over here. This is the power cord. Okay, this is used to power up the system. Okay, and this is serial communicator. This is USB connection port. Okay, and this one whatever you can see is a JTAG port. That means if I want to connect a JTAG, I can connect it over here, right? So this overall board, okay, and this one you can see it over here. These are the keypads. These are nothing but what? Keypad. That means I can interface a keypad to this kit. So this overall board is of consists of all the peripherals that should be connected to this board, and also there is a motherboard is also there. Correct? So this board we are trying to program it. We will try to program it. Okay, and then we'll see how does then output will come. Okay. And for the VTU students, this is the syllabus that has been put forth by the university. Okay, and they are having around 13 experiments are there. There are around 13 experiments are there. First 5 are part A, and next are part B. Okay, next 8 are part B. Okay, so first 5 are assembly level language programs, right? So all are assembly language programs. First 5 are assembly language programs. And next 8 are, we should use embedded C program. Next 8 we should use what? We should use embedded C program. Okay, so this is how the syllabus has been modified, has been kept for the 6th semester VTU students. Okay, so first one will study some of the programs which are simple, okay, which are 8051, right? So what is that? The program states that write an assembly level language program to add 2 8-bit numbers using 8051. 8051 is what? It's a microcontroller. Okay, it's a 8-bit microcontroller, right? So the need is that before studying ARM programs, we should have some input for 8051. We should have some input for 8051 programming, right? So that's the need. So that's why what we are trying is we are trying to give some of the input for 8-bit numbers. Okay, so first statement is org000h. Okay, so this is the starting address of the microcontroller. This will state the starting address of the microcontroller. Now I need to put 2 data into the register. So here move A into immediate data. So that's what A stands for accumulator. What I am doing, I am moving 02 into the accumulator. Okay, then what I am doing, I am moving the 02 into the register R1. Okay, so what I will do, I can add A comma R1. Okay, I can add A comma R1. Okay, so this A, which means what? Okay, in microcontroller 8051, whatever the operations you do should be done with respect to what? Should be done with respect to accumulator only. Should be done with respect to accumulator only. In microcontroller 8051, accumulator. Okay, should be done with respect to accumulator only. So it means what? The destination register should be accumulator. The destination register should be accumulator. So after this, what will happen? Whatever the data will be there will be added and will be kept into the register A. Then we have used an instruction called as loop, simple jump or short jump loop. That means what? The loop will be over here only. Okay, so it means what? The data, okay, the program counter will be there into this, and it will enter into infinity loop. Okay, so some of the processors, okay, so they need infinity loop. They need infinity loop. So that's why they have been put into loop. Okay, then the next instruction is end. So when we execute this, the output of that will be 0 for H. Okay. Similarly, 8051. So if I want to subtract two numbers, what will happen? I should use, instead of add, I should use SUB instruction. So this is nothing but it will subtract A minus R1, and then it is going to put the answer, which is nothing but 0 to H. So this is what the instruction, this is what the experiment that is there for ARM instruction. So here there is assembly level language program to multiply two 16-bit binary numbers. Okay, to multiply two 16-bit binary numbers. Right. The first and foremost thing is, for every ARM board, you are supposed to include the wordings called as area. Okay, so this area, what is this area? This area represents where you are writing the code. Then this is what, this is the name of the program. Okay, this is what code mean, where the data gets stored, and this is read only. Read only mean what? Okay, after the data is stored, okay, the code becomes read only. Then we are using export underscore main. Okay, so this one is to export the assembly coding into C language, into embedded C language. Then we are starting with the main. So as we are dealing with 16-bit binary numbers, so it is going to be move R2. So this one we are moving R2 into this R2, and again we are moving 2 into this R1. Then we are multiplying. Okay, then we are multiplying R2. Okay, we know that in ARM instructions are multi-operand instructions. Multi-operand instructions, right? So when we do this, what will happen? It is going to be R2 is equal to R2 multiplied by R1. Okay, when we do this, then if we have to put the processor into the infinity loop, so that's why we should use LBL. L is nothing but label, B is nothing but branch, and again label. So what is it? Is to branch to this label itself. Again this will happen, right? Then you are ending the program. So when you do this, when you execute this, you will find out that the register R2 contains this number, because you are multiplying two 16-bit numbers, binary numbers. Correct? Right. So this is what the experiment, that is to multiply two 16-bit numbers, binary numbers. Correct. So I encourage the students to just copy down this program and execute in Keel Microsoft Vision. Okay, execute in Keel Microsoft Vision 4. Okay, Keel Micro Vision 4. Okay, so this is the software that is used to execute this program, right? Just execute this, and if there are any doubts or something of that type, you can ask. Okay, so thank you.